Awesome.
Thank you so much, Taylor, and the developer advocacy team. They've done an amazing job, and all the MCs for Hashi Talks. This is really a really exciting event for us. This year, it's 48 hours, which is quite a lot of time to cover. And so, yeah, I mean, without wasting time, I'll get started here. So today I'm going to be talking about service mesh beyond the hype. So the idea of this talk is to kind of talk about some of the service mesh fundamentals that are often not talked about, or maybe people probably don't skim through them, right? So that's kind of the whole idea, and talk about what this hype is about. The closing of the talk is with some live demos. Hopefully they all work. I just finished working on them, so there might be some debugging here, live debugging here, but hopefully we can get through this. So as Taylor said, my name is Mishra. I'm the technical advisor to the CTO. I work in the office of CTO. I focus on strategic projects that go all the way from collaborating with cloud partners like AWS, Microsoft, and Google, and so on. I collaborate on open source projects. I do a bunch of advocacy work and so on. And kind of the main thing for my role is to kind of showcase and kind of think about the next 2 to 3 years for HashiCorp, and kind of look at the industry and do some research there. My background is in computer engineering. So I've been an operator. I've been a software engineer. So kind of understand both sides of the story here. So I empathize with both developers and operators. So currently I get to focus on all of the HashiCorp tools. I do, one of the things I want to talk about is where I live. And this is something really interesting to me because, Vancouver is where I live. And this is, it's about around 7 p.m. or so here right now, 7:05 p.m. or so. So good evening to everyone who's in North America. So this is where I live. It does look like that for like maybe 2 or 3 months, but then it turns into a lot of rain. It's a lot of rain for like 6 or 7 months or so, which is fine by us. Nowadays it's been pretty good weather here in Vancouver. I do love open source. I work on a bunch of open source projects for HashiCorp, and also I've created a few prior to HashiCorp. One of them is Atlantis, that helps you collaborate with folks on Terraform, and this is now part of HashiCorp. I've also worked on a few Kubernetes community-related projects. So Vault CSI driver, you might have used that. Virtual Kubelet, I'm a provider, maintainer for the Virtual Kubelet Nomad provider. And then I've more recently contributed to a project called Dapper, and they actually went 1.0, I think, more recently. I also sometimes host HashiCast. You should definitely follow and kind of listen to HashiCast, which is hosted by the developer advocacy team and community teams. Definitely a shameless plug here. I'm also writing a book. It's not that relevant. Okay, let's get right into the talk here. So service mesh, you might have heard of like this term, and a lot of people are talking about this, right? Like, and everyone's curious about what it is. So the origin of the term actually happened in around maybe 2016, 2017, when William, who is one of the, I think, creators of Linkerd, the company behind it, I think it's called Buoyant. They did a blog post about service mesh, and they released a service mesh or a proxy called Linkerd, which was the Linkerd 1.0, like the first version, which is written in Scala. And the idea here was to kind of have some retries and smarts and routing built into this other process, which is in your application, right? So this is where it all originated. Today, though, when you do a Google search, it's a lot of results, right? You look at these. There's like about thousands of results here, and all vendors are talking about this mesh thing, right? And it does look quite complex from far away. So I don't know if you all have seen this tweet, but this tweet was, I think, sometime in 2019. The Monzo folks tweeted about this, that they have 1,500 microservices, and every line is an enforced network rule that allowing traffic. So I don't know about you, but to me, when I look at this, I just look at like a lot of complexity and managing all those number of services at that scale. Hats off to the Monzo team, but it does look quite daunting, right? So I want to kind of talk about some of the basics and start from kind of the fundamentals, and then build up into talking about the mesh here. So before like anything else, really the problem is that one service needs to talk to the other service, right? Service A wants to talk to service B. You can do this really easily by hard coding IP of service B and service A, and that should just work, right? But in reality, you actually don't have one instance of a service. You have multiple instances, right? So this is where you have a service discovery issue. So basically, which of the service instances of service B should service A route traffic to? And this is one of the most fundamental problems that you get, when you go from maybe, running 2 web servers to 10 web servers, and, maybe a few of them talk to each other, right? It could be solved using DNS and many other ways, right? The other problem a lot of folks get into is when they roll out a new version of the application. So you may roll out level V1 and then you have V2. How do you, slowly and gracefully cut traffic over to V2? Can you even control the traffic, right? So this is where service routing becomes an issue, right? Then you have, service A talking to service B over the network, right? And we all know how reliable networks are. I was just being sarcastic. Like, networks aren't that reliable, and requests actually fail in real life, right? And so how do you go about, retries? Do you even retry? Should you even, should you think about like idempotency of the request? Should you think about whether this is going to do a database, right? And so on. So these are some of the questions that you're faced with when it comes to, the network, right? Then you have this identity problem where, let's say, service A wants to talk to service B, but if you do this over plain text, it's not great, because anyone can listen in and actually see what you're transporting from one service to the other. So one of the ways to solve this is using mutual TLS. So there is this issue of like, how does one service talk to the other? You need to assign specific identities to each one of these services. This might be a certificate that service A can use to do a handshake with TLS handshake with service B and establish a mutual TLS connection. So this assigning identity becomes an issue, right? And then if you extend this, like, should service A talk to service B? That's a big business level question, is like, should one service, API service, can talk to a DB service, right? So an authorization becomes an issue as well. So there's many of these challenges, right? Service discovery, service routing, service identity, authorization. You have retries, circuit breaking, traffic shifting, and then, of course, insights into your service. Things like observability also become a challenge when you come into this microservices world, right? So I want to talk about 2 of these, critical things, that what we call first principles, right? So the first thing I want to talk about is this idea of a dump pipe. So here, basically, this is basically, we've been doing this for a really long time, right? So here what happens is service A, when it wants to talk to service B, the discovery of service B, the retries, the traffic shaping, and so on, all that logic actually lives inside of service A itself. So in the application code, you can actually import something, or maybe write a library that allows you to do this. And this isn't a novel concept. As I said, it's been done for a really long time. One of the famous articles or libraries that you might have seen is Netflix's Eureka and Hystrix library, and this is what they went with, right? So there are some of the things that you need to consider in this, like, dump pipe concept. In this, essentially, the network itself is super dumb. It's not doing anything smart, right? It's just moving packets from one place to the other. But the application's actually doing a lot of heavy lifting here. So there's simplicity of networks. So you get networks are pretty easy to reason about. All you need to make sure is the 2 services can actually talk to each other. They're allowed to talk to each other in the cloud provider or on-prem, right? And you're off to the races. The application itself is smart. So you can actually, you basically see what you see is what you get. The idea is that if you are able to compile the application and you can run it, and 2 things can talk to each other, essentially. So they should actually just work as expected. There's no third party. There's no implicit dependency that the application depends on for doing discovery, for doing retries, and so on. And of course, you can customize this. This is just code, right? You can customize this for any need, right? So some of the cons here is that there's actually redundant code in the libraries, in the form of libraries. So you need to implement these libraries for every language. Let's say you're a polyglot company. It becomes really hectic to maintain like a Go library, a Java library, and then also update all the versions of it as you release more and more features in these libraries, right? So some of the drawbacks of a dump pipe approach. So the smart networking approach is where you basically see, the first principles is that, the idea here is to move all of that logic that we talked about, which was inside the application, now outside the application into a process maybe that's running alongside the application. So in this case, it might be, it might be a proxy. So that's running alongside service A and service B. So let's say service A wants to talk to service B, it can go through the proxy and the proxies can communicate here. And some of the famous, I guess, like more popular proxies, Envoy, Nginx, HA proxy, and this list is, it keeps growing here. So some of the pros of this smart network or the mesh approach is that there's basically little to no application code that's required to make these happen. It's super easy to use. You can, basically applications are super dumb here. They don't even know that they're talking to. They don't even need to know the IP address or who they're talking to. Really, just the name of the logical name of the service, and they call the local proxy, and the proxy forwards the request accordingly because all of the smarts is built into the proxy. So features like traffic shaping, service discovery, network policy control, and stuff just comes out of the box for you. Some of the cons here, and this is something that a lot of people actually don't talk about, or maybe don't even pay attention to. Some of the cons here is that the smart network or the proxy actually becomes an implicit dependency of the application. So this is really important. So no longer is the network hard to, it's easy to reason about. Like the holistic system is now much more complex because you are going from, the application to the proxy to another proxy maybe. So you need to figure out, you need to have better like insights or observability into your mesh in order to understand what's going on and reason things. Before all you needed was the application code, but now you need to understand how proxies work and the intricacies of the config and so on. All right, so talking about, how the mesh works, there are two portions of the mesh. There's the actual configuration part. So the proxy themselves don't automatically have the smarts, right? Something provides it that config. The service discovery data, the network policies to enforce, the certificates, all of that stuff needs to be provided to the proxy, and that's done by a control plane. And then the proxy itself is the data plane. So there's two parts to it, the control plane and the data plane. The control plane should be highly available. The data plane is something that actually does the heavy lifting, but can go in and out, right? So some of the control planes that you might know of course, HashiCorp Consul, we're gonna see how that works here. You have Istio and Linkerd. Some of the responsibilities of the control plane is traffic shaping, controlling the data plane, configuring the data plane, policy enforcement, and providing, service discovery data to the data plane here. Data plane, again, this is the same smart proxy approach. You have Envoy, Nginx, HA proxy, and some of the responsibilities are actually doing the heavy lifting, forwarding the traffic from moving the request from one application to the other. Doing things like health checking, load balancing, circuit breaking, and doing timeouts and so on are all responsibilities of the data plane here. All right, and the second thing I want to quickly talk about is this protocol awareness, which a lot of folks don't really talk about. So here, you really need to understand whether the mesh is compatible, is layer 4 compatible. What that means is TCP, UDP become your protocol, which are pretty much universally compatible. There's high performance because you're not actually inspecting the request. And then it's really difficult, to actually provide some of the cons is like to provide sophisticated request-aware features like maybe like host-based, header-based routing. That's not available because you're not actually inspecting the request here. In layer 7 service meshes, which are most service meshes, they allow you to do, complex routing decisions like cookie-based routing, host-based, path-based, and, different parameters where you can route, right? And this does at a certain scale, does lead to low performance. And this is something that you should be aware of, is that you're actually inspecting the request. Most people won't even care about this performance, but I think at certain scale, things do become a little bit lower performant than the layer 4 approach here. All right, service mesh in action. I'll talk about console. I'll try to make sure that I'm still in the time limit here because I have a bunch of live demos which I haven't tested yet. I'll quickly give a summary. So console was launched in 2014, so it's been here for a while. There's about 20K plus stars. I haven't checked this but more recently, but that was the last time I checked. Have about like 1 million downloads plus monthly. And we have customers running 30,000 plus agents in one data center, which is really large. And then Amazon more recently told us that it's the most widely deployed service discovery tool on AWS, which is a really great thing for console here. Some of the public users, you might recognize some of these logos that publicly say that they use console. Okay, coming into Console Connect. So Connect portion is the mesh for Console. I want to talk about some of the practical implementation details of the mesh, right? So we talked about the basics. Now we wanted to see how that actually works. So basically the mesh, in this case, Console Connect, provides you with automatic TLS, mutual TLS, identity-based authorization, and some L7 management that we'll see. And it works really everywhere. So on Kubernetes, on-prem, on EC2 instances, on your VMs, it'll just work anywhere. All right, and the way this works in traditional approach, as you can see, there's two IPs talking to each other. You might have a firewall in between, and you do some form of like firewall, like IP whitelisting or something like that to allow one IP to talk to another. So you have like some like allow list or so on. But in the mesh world, what happens is that IP is no longer relevant. The logical names of the services are relevant. So they get identity, and based on that, you make rules like, hey, Service API is actually allowed to talk to Service DB. Now we don't say that where Service API is. This might be in Kubernetes. Service DB might be running, in an EC2 instance. Doesn't matter, right? We just kind of talk about the logical names and we enforce that forward. And all of the communications happens via the proxy. So proxies, the API service talk to the local proxy, and that forwards the request up to the DB here, up to the DB. In this case, API is talking to DB. And in the previous case here, the web service was actually not allowed to talk to DB. And I'll show you an example of how that works. There you go. Yeah. So it's not allowed to talk to DB, and I'll talk about one of the examples of how this all works in console using intentions. All right. So Connect features. This is where the live demos begin, and this is where the danger area is, because I haven't tested a bunch of these demos, and hopefully, I really hope so, that it all works as planned, right? All right. So here I have two different things. I have a console cluster that's basically already up and running. It's running 3 console servers. It's running a mesh gateway, and I'll talk about what this is in a bit here. So the first thing I want to show is some of the practical, usage of a mesh, right? So let's look at like a 3-tier application. So we have a service web, basically a very simple Kubernetes deployment. The service really doesn't do anything. It just returns a text back that says, hello, I'm web service running in Kubernetes. But the important thing here is these annotations. So here I'm specifying the service name by using annotations to console, which is a special annotation here, console.hashicorp.com. So service web is the name, and my upstream is service API. And then if I go to service API, there my upstream is service hello, and service hello doesn't have any upstream. So it's basically service web call, service API. Web can be a website. API is just some API, and then the API is calling to some other service called hello. Very straightforward thing. So let's actually deploy this in Kubernetes. So we do a kubectl apply services, and I create this. Hopefully it works. Let me just check whether I am on the right Kubernetes cluster. Right, okay. All right, so you can see these are all coming up now. You'll also see these boot up in console. It takes a little bit. You don't need to refresh the console UI. It automatically updates here. So as you can see, all of this works. If I go to web, you'll see it's connected to API. So the topology view kind of helps you understand everything. And the web talks to the API, API talks to hello, right? Very straightforward. So now let's go to a special DNS that I have that you can actually access to see the output here. So let me move this away here. So if I go to, where is this thing? There we go. If I go to this this IP here, so you can see service web is talking to service API, service hello. And if I just see the raw output, you'll see that this is quite simple. There's nothing crazy about this, right? They're all returning these responses, right? Very straightforward. So let's do something really simple. Let's say we're rolling a new version for service hello, right? So we have, service hello here. Very straightforward. What we want to do here is actually create multiple versions of service hello. So if I go to another YAML file here, sorry, I'm using a bunch of YAML files here. So you'll see there's service hello v1. It's pretty much the same application, just saying that, hey, I'm version 1, and service hello v2. The special thing though here is I'm providing a metadata version, which is version 1, and metadata tag v1 here. And I'll talk about how you use these to kind of operate in console. Same thing here, we have version 2, v2, right? Pretty straightforward. So I can do here, I can go and say, first, what I'll do is I'll actually delete the service hello. Service split. Yeah, so I'll just delete this service hello deployment and then create these new ones, right? Kubectl apply service hello, which is basically going to create v1 and v2, right? So now if I go and if I see the UI here, hopefully in a bit, once these come online. This is where live demos are dangerous. Let me wait for the service to actually come online. All right, I think they should be online now. Oops. What did I break? Oh no. What did I break? Okay, let's see. Let's do a quick debug round here. Service is kubectl apply service is and service hello. So I'm going to create another deployment here. Okay, so it just took a little bit longer than expected. Okay, let me just delete this thing again. All right, so now that's good. I'll do a get pods. All right, so I think that's terminating. Okay, good. So we have these two services running, v1 and v2. We are back. We are back. Okay, good. So you can see how the hello service is going from v1 to v2, v1 to v2, right? So what we want to do is I'll just start a quick while loop here, just to just to make sure that we're actually able to see this change, right? And next, what we'll do is we'll actually just watch this, right? What we'll do is we'll actually split traffic between these two, right? So let's do that. So in order to do that in console, what you end up doing is you create a service splitter, and in order to create the service splitter, let me move this over here. You actually need to define some service defaults here. So we have something really simple. You won't even notice what it is. It's very simple. So all we're saying is service hello is an HTTP service. So we want to say by default all services are TCP. So we'll just do console config write, and we'll say service hello is a default service. Write that. Okay, that shouldn't do anything. Now the next thing we want to do is create a subset for this service. So we want to say, hey, there is two subsets to service hello, which is service v1 and service v2, and a default subset. Basically, all default traffic should be going to v1, right? That's kind of the idea here. So we want to do console config write, and I'll create the service resolver. And this itself also shouldn't do anything here. Let me write that. All right, so this itself shouldn't change anything. You'll still see, hopefully, oh yeah, right. So the default subset is v1. So in this case, you're seeing a bunch of traffic go here. All right, so next thing we want to do is do the actual splitter that allows us to split traffic. So if I cat this file, here you see how I have like v1 should get 0 traffic, v2 should get 100%. Let's change that. Let's change that to service hello split. Oh, Vem's not here. Okay, that's okay. Let's use VI. Let's say hopefully VI is in here. All right, so we want to change this to let's change this to, let's say 50. Let's change this to 50 as well. All right, and then we'll do console config write service hello split. So this should hopefully split stuff in 50-50. And as you can see, there's version 2 showing up and version 1 showing up. So far the demo gods are with me, and I think this is going really well. This is more than what I expected. I mean, I have more ambitious demos, but this is more than what I expected. So let's do this one more thing. So what we'll do is, let me open this again. Oh my God, it's VI, right? Yeah, there we go. So let's move most of the traffic. Let's say you're happy with version 2 of the application. You can just move to version 2 completely. You're saying like, hopefully everything just works out. So let's write this again. And now if you'll notice, hopefully once this is written, all you'll see is version 2, which is what we see here, right? So far demos are going great. No issues, I shouldn't worry about it at all, right? The one other thing I want to try is to show you some of the kind of the authorization things that I talked about here. So let's say you want to say, all the traffic that's coming from web to API, you want to just stop all that traffic, right? So how does that work? So you can actually go and create an intention, which is basically a human way to describe a rule between two logical names of the service. So I want to say everything coming to service API should be just drop everything, right? So when I save this, hopefully what you see when I go here in the UI, you'll see an error, which is 403, which is basically you're not authorized to do that, right? And as soon as when I remove this and I go back here and I refresh, you see we are back again, and all of this happens using validation, right? The authorization enforcement that happens on this console server here. All right, so that's the first demo, right? This is exciting, all works as expected. So now let's say you want to think about joining another data center in console. So you want to maybe have some EC2 instances running on some other region. You want to join these, and how does that work? So let's quickly, before we run out of time here, I'll quickly show you a demo here, which basically talks about the mesh gateways, which I think I won't have the time to describe here. So basically allows you to communicate across networks, and they don't need to have they can have overlapping IP addresses. So basically you expose a mesh at the edge right there, and then you allow, a failover from one DC to other, or maybe a redirection from one DC to the other. So here what happens is the service API does not need to know IP addresses in service DB. All of that is handled by the mesh here. So I'll quickly show this. So before I do that, what I'll do is let me delete all the services that are running here. So kubectl delete. Actually, before that, let me just quickly clean up here. Clean up. Oops. Clean up. So if I do this, should be able to clean up. Should be able to clean up. All right. So that's all good. Oops. Oops. Oh, okay. 1 second. Why is that? Okay, there we go. And if I clean up this splitter here, resolver here as well. All right, I think I have, I've cleaned up both these things. All right, so next thing what we want to do is just quickly delete these services. kubectl delete, I'll do a service split, and I'll delete the service hello that was running. All right, and then what I'll do is I'll quickly apply the original service hello that was running. So kubectl apply Kubernetes services and service hello. All right, so now hopefully we have, if I do get pods, hopefully we have 3 of these things. Okay, so they're all up and running. They should be talking to each other. Everything should just work. Now what I want to do is I want to switch to a different cluster, and I won't say where this cluster is, okay? So I'm going to switch to a different cluster. This is some other cluster, some other Kubernetes cluster, and I want to create a bunch of services here as well with the same names, basically. So we want to redirect things here, right? So we want to do kubectl apply DC2 and create these 2 services, right? So if I do get pods, you should see only service API and hello coming up. So we can validate this. So you can see service API and hello coming up in this mysterious DC2. We don't know where this is, right? We don't know where this is. So hopefully this thing comes online. All right, so we are all healthy here. So now let's redirect traffic from DC1 to DC2, right? How do you do that? So I can go to service redirect folder here. So what I have to do first is basically define a default for service API. Just tell console that, hey, instead of TCP, just use HTTP for this service. So I'll do console config write service API default, right? That'll create it. And then we'll just do a redirect. So before I do that, I actually want you to notice what happens here, which is quite magical, right? So I want you to notice, since we are redirecting service API, I want you to notice this block, and especially this text here, right? It says, hello, this is, API service on Kubernetes, right? So hopefully if this demo works, we're in luck here. Like if the first few demos worked, I was pretty happy about this. So let's do a console config, right? Service API redirect, right? This should hopefully redirect the service. So as soon as I apply this, did it work?
And how do you measure? Unfortunately, it is time and time to switch to somebody else, but just wanted to drop in.
Oh yeah. I'll just quickly roll, finish up here. All right. So I guess this did not work at all as expected. So the idea was to kind of show a full failover here between one DC to other. Oh, actually, it might have worked. Okay. Regardless, I'll tweet out something that probably shows this portion of the demo, so you can check out my my Twitter here. So let me just quickly end here. All right. So yeah. So in conclusion, Consul is the fully featured mesh, supports multi-cloud and multi-region. And thank you. Follow my Twitter. I'll don't follow it. I just check out the Twitter. I'll hopefully put a video of showing this failover. It should be exciting. Thank you so much. Sorry for taking extra time here.